So high level and low level languages and their translators. So how actually are languages, what are computer programs, how they look like, why do we make them? That is a topic for another day. Today we are going to just discuss the differences and their working, and when afterwards we will get what will we say, जब हम इसके अंदर गहरा जाएंगे मजीद जाएंगे, we will discuss further in it. So then we will discuss about those terminologies and all. So high level languages in short are those languages which we when see, तो हम उनको आसानी से we can see and understand them. Low level languages are actually the languages which we can read but we have hard time understanding them. And then there comes machine language which is purely in binary. So usko to we cannot understand at all. So for just one example, let's see, this is one of the statement of high level language which says that A is equal to B plus C. A is equal to B plus C. So this is very simple statement which is an arithmetic operation statement. So this in blue is basically high level language. A is equal to B plus C. But if we have a look at that same purpose holding program in low level language, so we don't have one statement anymore. We have got three statements. These three statements are doing the same as this one high level language statement. What does it mean? It means कि आपके पास जब एक हाई लेवल लैंग्वेज की स्टेटमेंट होती है तो उसको आप ह्यूमंस पर्सपेक्टिव में देखते हैं और समझते हैं और दैट इज क्लोज टू योर अंडरस्टैंडिंग. Whereas low level language is made with the idea of computer's processor and with the perspective जहाँ पे processor उसको देखकर आसानी से समझेगा. So the high level language which is easily understood and learned by the humans, and there are, when they are written in English like sentences, whereas low level languages they are hard to remember but they can be remembered because there are persons who are basically programming in low level languages and they are very close to machine languages. How, we will see later. So you can see that for one high level language instruction there are many low level language instructions. For one high level language instruction there are many low level language instructions. So we can say that if we have the same statement in low level language, we as in high level language users, if we have a high level language statement and we try to develop equivalent low level language statement, then it won't be one statement, rather it will be more statements. So we can say the relationship between high level language and low level language is one to many. For one high level language instruction there are many low level language instructions. All right, so the first thing that you have to understand is there are times when you would have questions and you would have to recognize which one is high level and which one is low level. So the one that you can easily see, there are English like statements and you can make a sense of it with a little mind in it. That is high level language. And if you see something that you can read but that is not understandable until unless you have some assistance from somebody कोई आपको बताए तो फिर आप उसको समझेंगे, that is low level language instruction. अगर तो वो pure zeros and ones में होगा तो then this is machine language instruction. All right, so what the second thing is the difference between high level language and low level language instructions. Over here you can see high level language are basically easy to understand and learn and they are English like commands, whereas low level language instructions are hard to understand and learn, very simple and close to machine language. ये हो गई दो चीजें. Now third one is what is the relationship between high level language and low level language? Yes. So high level languages are English like languages that you can read and understand easily. Low level languages are uh, easy to read, but they cannot be understood properly. You can see over here the LLDB, ADDC, STOA. They can be read, but they cannot be understood until unless आपके पास कोई suggestion हो, कोई assistance हो, कोई आपकी guidance हो. So easy to understand, hard to understand. Then easy to remember, hard to remember, and they are very close to machine language, and these are close to humans. All right, and then there comes relationship. Relationship as in for one high level language instruction, there are many low level language instructions. So the relationship is one to many. Similarly, if you turn this low level language instruction to machine code, the relationship would be 1 to 1. For every single low level language instruction, there is one machine code instruction. So there are two relationships, high level to low level, there is 1 to many. Means for one high level language instruction, there are many low level language instructions. And for low level to machine code, this is 1 to 1. Means for every low level language instruction, there is one machine language instruction. Now, you can see over here, there is a code written. For I is equal to 1 to 10, output I next. So you can obviously see English words and sentences, and you can make easy sense of it. All right, with less guidance you can understand it on your own, but if it is like this you won't be. So it is high level language instruction and this is low level language instruction, and if you see anything written just in zeros and ones, तो वो आपके पास क्या होगी, machine language instruction. Now let's dig deep into it. Languages, there are two types of languages, high level languages and low level languages. ठीक है. Every language, चाहे वो high level language हो or it is low level language, it needs to be translated to basically machine code which is in binary form. Since computer can only understand, computer as in microprocessor can only understand if the instruction is in binary form, means it is in zeros and ones form. So no matter whether you write a computer program in high level or low level, that program needs to be converted to machine code. So basically क्या होता है कि every single program is having another program. जो program आप लिखते हैं उसके साथ एक और program आपको चलाना पड़ता है, उसको हम कहते हैं translator. So the program that you write, whether it is high level language program or low level language program, it is said to be source code. The program that I have written, that you have written, and you want it to work over computers, उसको हम क्या कहते हैं, source code. Every single source code requires to be converted to binary form. If it is in binary form, it can only be understood by the microprocessor and can be followed by the microprocessor. So if it is not in binary form, which is said to be machine language, it cannot be understood by the microprocessor, and the whole reason for making it will be wasted. So there are separate programs which are available with every computer language that turns your source code into machine code, and that program is called translator. What do we call that program? Translator. That takes your source code from high level or low level languages and convert it to the machine language or machine code. So the translator of low level languages is called assembler. There is just one assembly language for low level working. There is just one assembly language for low level programming. So whenever a processor is made, there is a language attached to it. That language is the processor's language, and that language is called assembly language. Every computer in the world has a processor, and that processor has a language called assembly language. Assembly languages for every processor are different. Assembly languages for every processor are different, but for one processor family, as in Intel's i3 processor or Qualcomm processor or Exynos processor or Bionic processor, these families have got the same assembly language, but every different brand of the processor would have a different assembly language. So basically what happens when you write a program, a translator turns that program into machine code. The translator for low-level language, which is also called assembly language, is called assembler. As the name suggests, assembler assembles the assembly language code into machine code. Assembles the assembly language code into machine code. It means it converts. All right. If it is high level language, then the translator is not the assembler, because assembler is only associated with low level language, which is assembly language. High level language, there are so many high level languages. You might have heard of Java, you might have heard of Visual Basic, you might have heard of GW Basic, Visual Basic, Python, PHP, Perl. There are so many different languages that you can use, and with every language there is one translator which converts the code that you write in that particular language into machine code, because ultimately every source code needs to be converted to the machine code. So for high level language, there are two types of translators. One is called compiler, the other one is called interpreter. One is called compiler, the other one is called interpreter. Now, the next question would be, what is the difference between compiler and interpreter? All right. The question might be, what is assembler? Assembler is the program that converts assembly language programs or low-level language programs into machine code. But for the translators in high-level languages, which are compiler and interpreter, the question will mainly be the difference between these two. All right. We will discuss about these differences थोड़ी सी देर में. Let's first discuss that translator हाई लेवल लैंग्वेज का आपने ट्रांसलेट किया, कंपाइलर ने उसको कंपाइल करने के बाद मशीन लैंग्वेज में कन्वर्ट कर दिया. ऑलराइट. और एक और ट्रांसलेटर है इंटरप्रेटर, उसने कन्वर्ट नहीं किया. असेंबलर जो है वो कन्वर्ट करके मशीन लैंग्वेज का प्रोग्राम बना देता है. कंपाइलर कन्वर्ट करके मशीन लैंग्वेज का प्रोग्राम बना देता है. इंटरप्रेटर कन्वर्ट करके मशीन लैंग्वेज का प्रोग्राम नहीं बनाता. लेट्स सी व्हाट इबाद हैज सेड. कंपाइलर एग्जीक्यूट्स प्रोग्राम कोड वंस the code are compiled. This is bit a wrong statement. Let me explain it. ठीक है इबाद, this is a bit wrong statement. Not wholly, but yes, a little. I'll explain it. Neither compiler nor assembler execute the code. They just turn the code into executable form, which when executed is executed separately. तो इसको हम ऐसे कहते हैं कि once the machine code is made, compiler or assembler is no more required. Once the machine code is made, they are no more dependent over compiler or assembler. They can be executed on their own. So they are in the form when processor reads them, the machine code processor executes it itself. Neither the source code nor the compiler or assembler are required. So source code you have written, you have use the compiler to convert it to the executable form. Now no source code, neither source code, sorry, or nor the compiler is required. The machine code will work on its own. Whereas the interpreter doesn't work that way. Interpreter is basically a virtual machine. What is a virtual machine? Virtual machine is the software form of hardware. What is virtual machine? A software form of hardware. So what basically happens that interpreter itself reads, converts and executes it. You need to understand this. The compiler and assembler, they take source code as input and give the output as object code or machine code. Whereas interpreter takes the source code as input line by line and executes it, converts it itself and executes it. It doesn't produce any output for the processor to compile it. I hope that it would have made it clear that interpreter executes, translates and executes, whereas the compiler and assembler translates, they do not execute. Then the code is executed afterwards. So whatever the program that we have, when we execute that program, it means it is in machine code. Whenever we have a program and we install it, it is in machine code. Installed program means it is in machine code. Machine code means it does not have any source code or compiler attached. It is on its own. All right. So get the idea. Interpreter does not convert the source code into machine code. It takes one line at a time, reads that line, converts that line, and executes that line. That's it. Whereas compiler takes the whole source code, assembler takes the whole source code, read it as a whole, complete program, and converts it to the machine code, and they get free. Now that machine code, which is made in the form of a file or a program, can be executed separately later. Good. So interpreter is called what? Virtual machine. Why? Because it is playing a role of microprocessor, because it does not use microprocessor. It does not create the executable file which later works on over the microprocessor. It itself works as the microprocessor. When it works as the microprocessor itself because it is executing the program, we call it virtual machine. Virtual machine means a software which is basically acting like a microprocessor. So basically what happened when the time of high-level languages started, people basically wanted to work with high-level languages, because high-level languages, if you compare them with low-level languages, are easier. They have got farther reach, they have more possibilities, because you don't waste your time learning much. Rather, you basically put your time in understanding and innovatively using high-level languages. We will discuss this when we will be studying P2. But the problem is that compiler is memory hungry. What does it mean, memory hungry? Memory hungry means a program that takes a lot of RAM. Nowadays, the RAM in our era is cheaper. It is available for peanuts. But there was a time when the RAM was very expensive. It was not enough available for the computer that we purchase. And if you want to add more memory, you had to spend sometimes more amount than the whole computer. So what happened when people realized that compiler takes a lot of memory, that is why we call it memory hungry. So they did not adapt the compiler. They said that we are good with low level languages, we cannot afford to have compiler, because if we like to use the language that needs compiler to convert our source code into machine code, we have to have more RAM, and that RAM is so expensive we cannot afford it. So then scientists and engineers invented interpreter. Interpreter is a shorter program. It doesn't take a lot of memory. It is not memory hungry, and it basically converts and execute the source code itself. It doesn't require the processor. So you got liberated from a processor that is basically latest. You got liberated from the RAM, which is basically vast. So you can use interpreter over an ordinary computer with the interpreter. There is a general misconception and misunderstanding that interpreters were invented before compilers because their work looks primitive, older, but that's not the thing. Interpreters were made later after the compilers because compilers were memory hungry. So you should keep it in mind. And then interpreter is in a way is more advanced because it is mimicking the processor itself. It is basically working, it is executing the program itself. World's most used language, most popular, most flexible, most user-friendly language, Python, is basically interpreter based. All of the codes which work inside the browser and they are written in HTML files, they work with interpreters. There are no compilers for those. So interpreters are pretty much popular. They are not obsolete. They were not primitive. They were made after compilers and they made the life easy. So people started adapting high level languages because of the interpreters. Had there been just compilers, a little people would have adopted high-level languages based on compilers, and those who are making compilers would not have made it क्योंकि लोग खरीदते ही नहीं है चीज तो वो बनती है बढ़ती है ना जो लोग खरीदते हैं अगर सेल फोन्स को हमने परचेज करना शुरू नहीं किया होता तो लोगों ने इनोवेट करना शुरू नहीं किया होता हमने परचेज करना शुरू नहीं किया होता तो लोगों ने उसके नए नए मॉडल्स नहीं बनाए होते उसमें मजीद रिसर्च नहीं होती और आपके पास इतना बड़ा एक सेल फोन होता जो आप ऐसे करके इस्तेमाल कर रहे होते सो इट इज बेसिकली द एडेप्टेबिलिटी the common users adaptation for something which basically make these producers do more research and bring you best things. So interpreter is an advanced form, although it works slower than compiler, but most of the languages nowadays which are most popular like Python are also using interpreters. Anyways, we are not here to support interpreter or compiler. We are here to understand why compiler is memory hungry and why do we need to compare compiler and interpreter. So let's first discuss that why compilers are memory hungry. I hope that you understood the term memory hungry, a program that takes a lot of RAM, a lot of the word a lot of is relative word. अगर आपके पास कम मेमोरी है तो उसमें से अगर किसी ने वन थर्ड ले लिया तो a lot of हो गई लेकिन अगर आपके पास 16 GB मेमोरी है और किसी ने 3 MB ले लिया तो nobody cares. So it is relative term. A lot of means that when memory was expensive, people had less memory, and most of the part of that memory was taken by the compiler. So that is said to be a lot of. But nowadays, the same compiler, when it is loaded in my computer, because I have got many more GBs in my RAM, I don't care. For me, it is less. So there were times when memory was actually very expensive. So let's first discuss that why compilers are memory hungry. Compiler is memory hungry or used to be memory hungry because it used to get loaded to the RAM. Remember the word load. I told you that it is load, upload or download. When you want computer to do anything, you have to bring it to the computer's RAM. If you want to use that program, execute that program, make it successful or advantageous for yourself. So then you have to load it. If you want to load it, you have to bring it to computer's memory. If you want computer to have a look into it, execute it, you have to have it in computer's memory. So compiler, when works, it gets loaded. So when it loaded, it is itself in the computer's memory. Then, and I told you that compiler takes the whole source code, because it is not executing it. The aim of the compiler is to take the whole source code and convert it to machine code. So it needs to have the whole source code in computer's memory. Pay attention over here in this area. So compiler is loaded, the whole source code is loaded. Then compiler is working out the source code to convert it to machine code. That working out area is also required in the memory. All right. So let's say I'm a good carpenter. Somebody came to me and they want me to make a beautiful table. I said, okay, I'll make it. And then I require some space where I can use my tools to produce that table. So that space is also required by the compiler to turn that source code into machine code. So that is third thing, space. Now, once the space is used, machine code is produced. Now, machine code also requires memory. So when machine code also requires memory, then it means that there is compiler in the memory, the source code is in the memory, working area is in the memory, machine code is in the memory. So these four things are now in the memory and they are consuming a lot of memory. Once it is done, then you can save that machine code over your hard disk as a program file that you can execute later. So if the question comes that why does compiler take a lot of memory, or why compiler is memory hungry, so you would have to tell that it loads itself, it loads the source code, it requires some memory space, and then when it generates the machine code, it also holds that machine code in the RAM. That is why it is said to be the compiler is memory hungry. But the real advantage of compiler is whenever you will be producing an executable file with the help of compiler, that executable file will execute faster because it does not require any more reading in the source code thing and the conversion of the source code into machine code. Machine code is there. Machine code is the last thing. Think about two heads of the states. Let's say a Chinese president is talking to King of Saudi Arabia. Now, the king of Saudi Arabia talks Arabic. They do not know any other language. Chinese president talks Chinese and they do not talk any other language. So, Zafar Ali Khan sitting in the middle. All right. So, when Chinese talks Zafar, because he understands both the Chinese and the Arabic, it will be transferred from Chinese to Arabic and will be told to King Abdullah, maybe. And when King talks, Zafar understands in Arabic, turns it to Chinese and tells to Chinese president. And this is going on. So Zafar is taking more time because he is understanding, converting, telling. There are three things added. Let's say King of the Saudi Arabia knows Chinese, and Chinese president understands Arabic. Or they both know English and they are talking to each other directly. So those three extra works being done by Zafar to understand, to convert, and to speak are now gone. So the work is now direct and it is fast. So when the compiler takes the source code is converted to machine code is directly in the language which is understood by the microprocessor. It does not require any further loading or conversion or any memory working. It is right in the form which can be understood by the microprocessor directly. So the code that is produced by the assembler or the compiler works directly over the microprocessor and it is way faster. Now, if the code is being interpreted rather than being compiled, every single line will be loaded, translated, and then executed. Then again loaded, translated, and executed. Then again loaded, translated, executed. So if it is a loop where you like your program to repeat certain lines 100 times, if those lines are three, like three lines over here, if it is compiler, compiler will read these lines once, convert these lines once, and that's it. And then processor will execute them 100 times because they will be already in the form which is understood by the microprocessor. But if it is interpreter, interpreter will read these lines 100 times, convert these lines 100 times, and executes these lines 100 times, and this would be the common scene. So interpreter is way slower, whereas compiler is much faster because compiler works as fast as the microprocessor, but interpreter works slow. So now the differences between interpreter and compiler. Compiler consumes the whole source code. It is tough to debug. What does it mean debug? We will discuss about it later, but let's have an idea of it. Debug is basically bug. The word bug is used for any flaw, error in the source code which is not letting it execute, or if it is being executed, the result is not as we expected. समझे आप लोग? Bug is a situation जहां पर आपने जो सोर्स कोड लिखा है या तो वो चल नहीं रहा, या अगर चल रहा है तो वो रिजल्ट प्रोड्यूस नहीं कर रहा जो आप चाह रहे हैं, तो आप परेशान हैं, आप अपने सोर्स कोड को चेंज करके सही करने की कोशिश कर रहे हैं, हर प्रोग्राम ये करता है, तो उसको कहते हैं बग. In modern times, it is no more called bug, it is called exception because it is something which you have never expected, so you never have written. Had you expected it earlier, you would have written the right source code. So this is exception. I have done everything except this. So that except this thing is now basically making my source code no more working. Anyways, so bug. So there was a time when computer was invented for having zeros and ones. They used to have thermal tubes. जैसे हमारी ट्यूब लाइट होती है ना, ऐसी मोटी मोटी 3-3 फीट की ना थर्मल ट्यूब होती है. थर्मल ट्यूब का साथ ना मोटी मोटी तारें लगी होती थी. जब ट्यूब गर्म होती थी तो उसकी हीट जो है वो तारों से ट्रांसफर होती थी, तो उससे पता चलता था 1. जब वो ठंडी हो जाती थी, उसकी तारों से हीट ट्रांसफर नहीं होती थी, तो कहते थे 0. Thermal tubes. So those thermal tubes were so hot that once in the computer, and remember that computer was not that small like nowadays. Computer was way big. When I say computer, I mean the microprocessor, that people used to walk inside it because every single zeros and one had an associated fat, tall thermal tube. And when thermal tubes are up, people were not able to walk in between those, among those. All right. So once a giant bug, the hill bug, the bigger giant bug, entered that computer and got melted. Once it got melted, the heat transfer from the tube to the sensor got disturbed. Because of it, the whole computer's working got disturbed. So people took some time, like 3 days to 4 days, to understand that what sort of error is in the hardware. So they realized that a giant bug got melted and that mess of it is now not letting that heat pass through the wire. And that is why from that point onward, they started calling it bug, which is no more. So bug is like an error, and debugging means we are actually removing it. By the way, in English slang, we also use the word bug like don't bug me, but that has nothing to do with it. Now, so tough to debug. Tough to debug means, as we know that compiler takes the whole source code, and if there is a bug on one of the line, it does not stop there. It shows that bug over the screen and goes on. So if there are 100 bugs, it takes all the bugs and throw it over the screen and goes on until unless it scans the whole source code, it does not stop. So if over the course of those scanning for the transfer from the high level to low level, machine language, the translator does not stop. It just finds a bug, throw it over the screen, finds a bug, throw it over the screen. So for the for the programmer, it becomes overwhelming. Programmer परेशान हो जाता है भाई कौन सा सही करूं कौन सा नहीं करूं इतने सारे bugs आ रहे हैं. Alright? और अच्छा दूसरा एक issue ये भी होता है कि एक bug से दूसरे bug बनते हैं. This is a ripple effect. One bug gives rise to another bug, another rise to another bug. So there was a teacher of mine. He said that do not worry that how many bugs are there. What you do, you just take care of first initial 2 or 3 bugs, and as soon as those program errors are removed, rest of the errors will be reduced automatically. All right? तो कहते हैं ना एक झूठ को छुपाने के लिए 10 झूठ बोलने पड़ते हैं. तो अगर आपने एक सच बोल दिया तो वो 10 झूठ नहीं बोलने पड़ते. बिल्कुल ऐसे ही आप शुरू के 2-3 एरर्स अगर खत्म कर दें तो नीचे के बहुत सारे एरर्स खुद ब खुद खत्म हो जाते हैं. तो ये सिर्फ आपकी एक्सप्लेनेशन के लिए मैंने बताया. सो इट द कंपाइलर इज टफ टू डीबग बिकॉज इट throws so many errors over the screen that the programmer becomes overwhelming that what to do and what not to do. But everything can be done. So it is tough, not possible. It is tough but possible. Generates.exe file means it generates.exe means executable file which can be then separated from the compiler and source code and can work on its own. ठीक है. कॉपीराइट इश्यूज भी नहीं होते. ऑब्वियसली जो मशीन कोड है उसको तो कोई माइकल देख के समझ भी नहीं सकता ना. व्हाट इज कॉपीराइट इशू? कॉपीराइट इश्यूज इज like I have done something and you have copied it and presented it to someone else as your own work. Not just that, you have asked for some money as well. So I am here who produced it is not benefited, but you who have copied it, stolen it, not just selling it, taking back financial benefits, but you are making your future as well. And the one who has made it is not. So this is said to be copyright. Copyright. Copy as in you are copying my program, right as in my right to have money if I allow you to copy my work. So copyright, it's a law term. So copyright issues. So since the program is in binary form, no one can change it, no one can sell it further. So there are no copyrights. This copyright is only limited to the source code. All right. Runs directly over the microprocessor. Now there are few consequences of running a program directly over the microprocessor, and those consequences are if the program has a bug, that bug shows up during the execution of program, that will jam the program will get stuck. Not just the program, processor will also get stuck. If the processor gets stuck, the whole computer gets stuck. All of the programs which are running are no more and computer is hung. So this executable file can make this computer hang as well. Okay, so compiler is fast, way fast. It consumes whole source code. It is tough to debug. It generates an executable file. There are no copyright issues, and the code that it generates works directly over the microprocessor. On the other hand, the interpreter is basically much slower because it is taking every line, converting it, executing it, then taking another line, and it is doing everything slow. It consumes not the whole source code, but one source code line at a time. It is easier to debug. Why it is easier to debug? As soon as there is an error over a line, it stops. It says that this is the error, I'm at this line, correct this error. Once you correct it, then we will go further. Unlike compiler, which does not care if the error is there, it takes the error, throws it over the screen so that you know that there is an error, it goes on. Compiler does it. On the other end, interpreter says, oh, there is an error, please correct it, I'm here, halted, waiting. So it is easier to debug. And then it does not produce any of the executable file. It is basically emulator itself, emulator or virtual machine. You might have played PS2 games or cell phone games over the PC. So if you have played PS2 games over the PC or your cell phone games over the PC, the program that enables it is basically the emulator or virtual machine. Basically, that machine deceives these programs or games to be the processor itself for which they were made. So they work happily. But that program is not the processor. It is a software which is pretending to be the processor. And that is why those games which were written for a cell phone or for PS2 are being executed. So this interpreter is a virtual machine which pretends to be mimics a microprocessor, and it basically takes one single code of line, converts it and executes it on its own. When it converts and executes it on its own, it means it doesn't go down to the processor. So if there is an error, processor will not be stuck. System will not be hanged. So does not crash the computer. Compiler's output can crash the computer, but interpreter's output does not crash the computer. And there are copyright issues. Why there are copyright issues? Because if you give your program to someone else, that someone else will be required to have your program as in source code and the interpreter both. Interpreter on the person's computer who had you given the program will do the same as it is doing over your computer. So जब आप किसी को प्रोग्राम देते हैं तो आपको अपना सोर्स कोड देना पड़ता है, साथ में इंटरप्रेटर भी देना पड़ता है कि भाई जान ये इंटरप्रेटर ले लो, ये मेरा सोर्स कोड ले लो, आप चला के देखो। अब वो जो भाईजान है वो अगर किसी को बेच दें, उसमें अपना नाम, क्योंकि सोर्स कोड उनके पास आ गया, आपका नाम हटा के अपना नाम डालें और बेचना शुरू कर दें और आगे बढ़ाना शुरू कर दें, तो आप तो गए। तो आपका कॉपीराइट जो है वो इन्फ्रिंजमेंट हो गई। इन्फ्रिंजमेंट का मतलब है आपसे पूछे बगैर किसी ने आपका सोर्स कोड, क्योंकि आपने उसको दिया था, इस्तेमाल कर लिया। ऑलराइट, आ गई ये बात समझ में? तो ये इनके डिफरेंसेस, अभी सारे डिफरेंसेस लिखने नहीं होते, ये आपको बस याद करने हैं और आपके पास वो आएगा ट्रू फॉल्स ट्रू फॉल्स। आपको पता है हर टॉपिक के आखिर में मैं आपको जब पास पेपर्स करवाता हूँ तो उसमें मैं करवाऊंगा तो आपको समझ में आ जाएगा। तो जनाब अब एक आखिरी चीज रह गई, ये तो मैंने आपको बता दिया कि इंटरप्रेटर जो है वो एमुलेटर है। एमुलेटर का एक नाम शेल है, एक वर्चुअल मशीन है, आप जो भी उसको बोले आप बोल दीजिएगा। यहाँ पे एग्जीक्यूटेबल फाइल बनती है, यहाँ पे जो एग्जीक्यूटेबल फाइल बनती है उसको हम या तो ऑब्जेक्ट कोड बोलते हैं या मशीन कोड बोलते हैं, जो भी आप बोले, या मशीन लैंग्वेज बोलते हैं। वो भी माइक्रो प्रोसेसर पे चलती है और ये भी माइक्रो प्रोसेसर पे चलती है। इस इधर जो फाइल बनती है उसको कहते हैं .exe और इधर जो फाइल बनती है उसको कहते हैं .com, but .com doesn't mean .com as in over the browser, which is .commercial. Over here .com means command file. All right, so this was an overview. Now let's start having few definitions and all as usual, and then we will go further. Wait for a little. Let us start having few definitions and all. Now, please hold on for a moment. चलें शुरू करते हैं. So, what is a computer program? Program's definition. Program is a list of instruction that enable a computer to perform a specific task. That is a computer's program. Now, what is the term portable means? Portable. High-level language programs are portable as they can be used on different types of computers or different operating systems. All right. Now, what is problem solving? High-level language programs, high-level languages are problem solving as when used with this type of programming language, a solution to a problem can be set out as when used with or let's as when let's rephrase as when using this type of programming means high level programming programming languages, a solution to a problem can be set out in a way that is understandable to the humans as well as computer. So simply it means that we have got a problem, we wrote a computer program for it, and then that program is understood to us as well, and through the high level language compiler or interpreter it is more understandable to the microprocessor as well. So this is a situation where we use problem solving with high level languages and computers do the task as we require it. And then comes translation. What is translation? In general, translation is when translators convert high level or low level language to machine code. So translation has to take place before a program is written written in high level language can be used by a computer as computer works in machine code. So the whole purpose of translation is to convert your high level language program into the machine code so that machine code can be directly consumed by the microprocessor. So it has to take place before a computer program written in high level language can be used by the computer, as computer can only make use of machine code. So this is translation. So let's have examples of high level languages. Examples of high level languages. Now, there are high level languages like Visual Basic. There is Python, Pascal, C++. I think that's enough. All right, so etc. Now, uh, benefits of using high level language. Benefits of using high level language. So, what are the benefits of high level languages? Number one, basically, it is easier to understand. Understand for programmers, to read uh, the code as it is English like. All right. Second one, programs written in high level languages are easier for a programmer to debug. All right. Number three, development time is less. Obviously, it is in human-like language, so development time is faster. And last one is it is easier for one programmer understand and other programmers work. All right, that is why we had this copyright issue, if you do remember. Now, there are new terms now. Machine code. What is machine code? So what is machine code? So machine code is a binary language that a computer uses. It is the binary language that a computer uses. It is program instructions which are directly understandable by the microprocessors. Get the idea? So this is machine code. Now assembly language. What is assembly language? Assembly language is a low-level programming language. It is a low-level programming language that requires to be translated in the machine code form before it is followed by the computer. It is hardware dependent. What does it mean, hardware dependent? It means hardware dependent means the code that is generated over one processor does not work on a different kind of processor. Now, benefits of machine code programming. Or low-level language programming. All right. So benefits of machine language programming. So what are the benefits? Number one, programmers can write program to make use of special hardware. Low-level languages can be used to program directly for the special hardware. What does it mean? Let's say someone has created special hardware and they want to write a special kind of printer, let's say, and then they will write a program in assembly language for that printer, and we call it device drivers. So until unless that program is there, we cannot make use of the printer. So every special kind of hardware would have its own program written in low-level language. So when we write the program for the hardware, we cannot use high-level language, or we less use hard. Few of the high-level languages like C allows you to program in both of the ways, but for you as O-level student, whenever a new hardware is found, made, invented, a respective program is also written in low-level languages, because it is only low-level language that allows you to write programs for machines directly. Okay, number 2. Let's say if someone has invented a particular type of good processor, so if we make use of that processor, we have to have the assembly language associated with that processor. So programmers can write programs that can make use of special machine dependent instructions. Low level languages are used for writing processor dependent programs. All right, processor dependent programs means just to take advantage of that particular processor. And then programmers can write program code that does not take up much space in primary memory. So the best thing about it is the instruction size is so small that it does not take a lot of space in computer's memory. Or RAM. Now, programmers can write program code that performs a task very quickly. So low-level language programs are really fast. Because they were not made in any high-level language, which requires some translation and all. The code that is generated was with respect to this one particular processor, and this one particular processor's code that was generated in low-level language is directly written for that one processor. Means it is directly understood. There is no hanky-panky, there are no misconceptions, there are no missing on understanding by the processor. Since it is written for the assembly language, which is for that particular processor, it can be understood and followed up really easily. तो वो जो उस प्रोसेसर के लिए खास तौर पे लिखा हुआ है ना, वो सबसे ज्यादा तेज चलेगा. ठीक है. Now, आज के लिए इतना ही काफी है. कुछ और टर्म्स रह गई है, ये बोर्ड में आपको भेज दूंगा. So we will continue it tomorrow then. ठीक है. If there are any questions, please do ask those questions. ठीक हो गया. More secure from corruption, as in no. No. Every single program that is installed can be corrupted. When it is being downloaded, it can be corrupted. So what sort of corruption you are referring to? But I don't think that this program is on air, which you are saying that it is more secure from corruption. Is not a correct statement. I'm sorry for that. So I see you tomorrow.